Hello and welcome to Algebra 2, Lesson 71. In this lesson, we're going to learn about properties of logarithms. So in the last lesson, we started talking about logarithms. We showed what a logarithm was, and we showed how to go back and forth between exponential form and logarithmic form. Now, in this lesson, we're going to dig a little bit deeper, and we're going to talk about some of the properties that you're going to encounter when you're studying logarithms. So the first property you're likely to come across is known as the product rule for logarithms. So if you see something like log base b of xy, this is equal to log base b of x plus log base b of y. So what is this telling us? Well, essentially what it's doing is it's allowing us to write multiplication as addition. So in your book, you'll probably read the logarithm of a product is the sum of the logarithms of the factors. So let's reflect on that for a minute. I start out with log base b of x times y. So we can think of x as a factor, and we think of y as a factor, right? Those two are being multiplied together. And we expand this into, we say this is equal to log base b, so the base is the same, of x. X is the first factor. Then plus log base b of y. Y is the second factor. So if I saw something like log base 3 of, I don't know, let's say 2 times 5. This would be equal to log base 3 of 2 plus log base 3 of 5. Okay, very, very simple. You just take your first factor and put it there. Your second factor goes there. Very, very easy to do this. Now, there are some restrictions. We say x, y, and b. So x and y are the factors here. And it could be more than x and y. You can have 3 factors, 4, you can have as many factors as you want. But all those factors have to be positive real numbers, so greater than 0. Now, b, the base, has to be a positive real number. And then in addition to that, we have this added restriction. B has to be not equal to the number 1. So it has to be a positive real number, and it can't be 1. All right, so let's take a look at a few easy examples here. If we saw something like log base 3 of 7 times 4, again, all I'm going to do is just expand this. So this tells me I could rewrite this as log base 3 of 7, right, my first factor, plus log base 3 of 4, right, my second factor. So this guy went here, and this guy went there. Very, very easy, okay? Same thing here. So log base 7 of 12 times 3. This is log base 7 of 12. Then plus, you have log base 7 of 3. All right, let's take a look at another one. So we have log base 2 of 5 times 12. So it's log base 2 of 5 plus log base 2 of 12. Very, very simple. All right, now let's try to reverse the process. You might be asked on your homework or on a test to condense. So using the same property that we just talked about, if I saw log base 3 of 8 plus log base 3 of 7, I know I could rewrite that as log base 3, right? Log base 3 and log base 3. So it's just going to be log base 3 of, you've got an 8 here and a 7 here. So you would have 8 times 7, or you could really multiply those two together and say it's 56 if you wanted to. So let's say this is equal to log base 3 of 56. What if you saw log base 4 of 11 plus log base 4 of 5? So log base 4, log base 4. So it's going to be log base 4. And then of, you have 11 here and 5 here. So those are going to be multiplied together. So it would be 11 times 5, which we know is 55, so we could write it as log base 4 of 55. Let's take a look at another one. So if you saw something like log base 8 of 7 plus log base 8 of 5, what would you do? You have that log base 8. So that's log base 8 of, you've got a 7 here and a 5 here. So 7 times 5 will give me 35. So log base 8 of 35. All right, so very, very easy to deal with the product rule for logarithms. The quotient rule for logarithms is just as simple. So let's take a look at that. So if we see log base b of x over y, this is equal to log base b of x minus log base b of y. So in other words, the x in the numerator is going right here. The y in the denominator is going right here. So this is subtraction, whereas when we talked about the product rule, it was addition. Okay, it was addition. So we have the same restrictions. X, y, and b are positive real numbers, and b is not allowed to be equal to 1. All right, for the first one, we have log base 3 of u over v. So in other words, what I'm going to do is I'm going to say we have log base 3 of what's in the numerator. That's a u. Then minus, we'll have log base 3 of what's in the denominator. That's v. It's always numerator here. You'll have your minus sign, denominator here. Okay? The log base 3 will be the same in each case. So you've just got to work out what's going to go in this position and what's going to go in this position. Again, numerator is going to go here. Denominator is going to go here. All right, for the next one, we have log base 8 of 12 over 11. So this is going to be log base 8 of 12, what's in the numerator, minus, you'll have log base 8 of 11, what's in the denominator. All right, now we have log base 5 of 3 over 7. So this is going to be equal to log base 5 of 3 minus log base 5 of 7. All right, so now let's talk about reversing this process. So if I saw something like log base 9 of 10 minus log base 9 of 7, what would I do? Well, I know that I would have log base 9. Then of what? Well, I know it's this guy. The first one that appears is 10. That's going to go in my numerator. And then it's over. The second guy that appears is 7. That's going to go in my denominator. So this becomes log base 9 of 10 over 7. All right, for the next one, we have log base 10 of 7 minus log base 10 of 11. So we know this is going to be log base 10 of, you'll have 7 over, then you'll have 11. You just want to go in order. So 7 is first, so it goes in the numerator. 11 is second, so it goes in the denominator. So again, log base 10 of 7 over 11. All right, for the next one, let's look at log base 5 of 3 minus log base 5 of 8. So again, very, very easy. This is going to be log base 5 of, the one that appears first is 3, so that goes in my numerator. Then over, the one that appears second is 8, so that goes in my denominator. So this is log base 5 of 3 over 8. All right, so now we have the power rule for logarithms. So you have log base b of x to the power of r. And we say this is equal to r, which was the exponent here, multiplied by log base b of x. So in other words, the exponent just comes down and goes in front. Okay, that's all we're doing there. So again, x and b are positive real numbers, and b, again, is not allowed to be equal to 1. R is any real number that you'd like. So it can be negative, it can be positive, it can be 0, whatever you'd like it to be. So to give you kind of a quick example of why this occurs, let's say you saw log base 7 of 4 cubed. We could write this as log base 7 of 4 times 4 times 4. Now, using our product rule that we learned earlier, we could expand this and say this is log base 7 of 4 plus log base 7 of 4 plus log base 7 of 4. So I have 3 of the same thing. So I can just say I have 3 times that thing, which is log base 7 of 4. So that's all we're doing here. We're not doing any magic tricks. So if I saw log, again, base 7 of 4 cubed, this guy just goes in front. So we just say this is 3 times log base 7 of 4. Very, very easy. All right, so what about log base 4 of x to the 4th power? Again, this guy's just going to go out in front. So this is equal to 4 times log base 4 of x. What about log base 5 of the square root of x? So for this guy, you want to write it where you have a fractional exponent. So you're going to say this is log base 5 of x raised to the power of 1/2. And then you just want to bring this guy down. So this is going to be equal to 1/2 multiplied by log base 5 of x. What about log base 8 of the cube root of x? Again, you want to write this using a fractional exponent. So you would say this is log base 8 of x raised to the power of 1/3. This will be equal to, again, bring this guy down. So this will be 1/3 times log base 8 of x. All right, now let's talk about two special properties that you're going to come across in this section. And when you first look at them, they might look like gibberish, but they really save you a lot of time if you can identify them when you're doing your homework or if you're on a test or really any practice that you're doing. So if you see something like b raised to the power of log base b of x, you should know this is equal to x. Now, the restrictions here is that b has to be greater than 0, b is not allowed to be equal to 1, and x is greater than 0. So as long as those criteria are met, we're going to be good to go with this kind of formula here. And just to demonstrate this, I think when you see a numerical example, it'll make more sense for you. If you see something like 3 raised to the power of log base 3 of 7, what would this be equal to? Well, from just looking at this over here, you can kind of compare things and say, well, I know it would be equal to 7 because this guy right here, this b is here and here. I have a 3 that's here and here, right? So 3 is kind of in the place where b is in the generic formula. Then if I know that 7 is here, where this x is here, and then there's an x here, so a 7 must go there. So by that process, you can kind of figure it out. But you really want to understand where we get the answer of 7 from. It's a lot easier than just kind of looking at things and saying, oh, the generic formula says this, so let me just copy that. Think about what this part is right here, independent of anything else. If I have log base 3 of 7, this is the exponent that 3 must be raised to obtain 7. Well, my base here is 3. This is a base of 3. 3 is being raised to this guy right here, which again is the exponent that 3 must be raised to obtain 7. So whatever that value is, it doesn't matter. 3 is being raised to it, so I'm going to obtain 7, right? It comes from the fact that the base here and the base here, those are the same. So that allows us to just take this value right here, the argument in the logarithm, and just say that's going to be our answer here. If I had 7 raised to the power of log base 7 of, let's say, 30. Well, again, this is really easy. 7 is being raised to what? Well, log base 7 of 30 is the exponent 7 must be raised to obtain 30. So 7 is being raised to that value, so I'm going to get this right here. Again, the argument in the logarithm, the 30, so that's going to be my result. All right, let's look at another special property. This is another one that's going to be a time saver for you if you can identify it. So you have log base b of b to the x is equal to x. The restrictions here would be that b is greater than 0 and b is not allowed to be equal to 1. Now, for this one, it's something you just need to identify. You might see something like log base 5 of 5 squared is equal to what? Well, again, you can kind of pattern match and say, okay, well, there's a b here and a 5 here. So this guy right here would be this guy right here. And so my answer is this guy right here. It's the exponent. So the base here and kind of, you think about 5 squared, 5 is the base there in that exponential expression. So those bases are really the same. So what I'm saying is that 5 raised to the power of 2 would give me 5 raised to the power of 2, or 5 squared. That's all that's really doing. It's not very complicated to figure that one out. If I had log base 9 of, let's say, 9 cubed, this would be equal to what? 9 to what power would give me 9 cubed? Well, 3. It's always going to be the exponent as the answer there, because the base here, and again, when you think about 9 cubed, 9 is the base there, so those two are the same. So really, I'm just using the exponent as the answer. Okay, very, very simple. Now, where you might have to think a little bit, you see this on a test. Let's say you got log base 5 of 25, and you want to quickly figure this out. Well, 25 you should know is 5 squared. So the trick there is to rewrite this as log base 5 of 5 squared, and then you can quickly identify that, hey, 5 here and 5 here are the same, so I know the result here is going to be 2, right? 5 to the second power would give me 5 squared, or 25. So let's take a look at some examples. We have log base 6 of 6 cubed. So again, this part right here is the same as this part right here. So in other words, 6 to what power would give me 6 cubed? Well, it would be 3, right? 6 to the third power would give me 6 to the third power, 6 cubed. Log base 2 of 2 to the 7th power. Again, this part right here and this part right here is the same. So the answer is just the exponent right there. It's just going to be the 7. 2 to what power would give me 2 to the 7th power? It would just be a 7. What about 3 raised to the power of log base 3 of 8? Well, this would just be 8. Again, this logarithm that's the exponent here is the exponent to which 3 must be raised to obtain 8. So if I raise 3 to that value, I'm going to get 8 as a result. All right, let's take a look at some practice problems. So we want to expand each logarithm. All right, for the first one, we're going to look at log base 4 of, we have w times the cube root of x times y times z. So a lot of ways to kind of attack the problem here. But one way you could do it, we could say this is log base 4 of w plus, remember this is multiplication here, so it allows you to use the plus symbol. So we'll have log base 4 of this guy right here. So I'm going to use a fractional exponent here. The cube root of something is like raising it to the 1/3 power. So x times y times z to the power of 1/3. Now I'm going to take this 1/3 and I'm going to individually raise those factors to that power. So in my next step, I'm going to say this is log base 4 of w plus log base 4 of x to the power of 1/3, y to the power of 1/3, z to the power of 1/3. Okay. So now in my next step, I'm going to use the multiplication here to kind of further expand this part. So we'll say this is log base 4 of w plus log base 4 of x to the power of 1/3 plus log base 4 of y to the power of 1/3, and then plus log base 4 of z to the power of 1/3. Now, the last thing I want to do here, I want to use my power rule, and I want to think about these exponents here. Remember, I can write those out in front. So what I'm going to do is I'm going to say this is log base 4 of w plus, this guy's going to come down, so we'll say 1/3 times log base 4 of x plus, this guy's going to come down, so 1/3 times log base 4 of y, then plus, this guy's going to come down, so I'm going to say 1/3 times log base 4 of z. So my answer here is log base 4 of w plus 1/3 log base 4 of x plus 1/3 log base 4 of y plus 1/3 log base 4 of z. All right, for the next one, we have log base 5 of, we have 2 over 3 times 7 to the 6th power. This is all raised to the 4th power. So the very first thing I'm going to do is I'm going to raise everything inside the parentheses to the 4th power. Just going to get rid of this exponent here. So this is log base 5 of 2 to the 4th power over 3 to the 4th power times, power to power rule here, 7 would stay the same, 6 times 4 would be 24. Now, how do I work with this? You have a division inside of here. So remember, the numerator here is going to go first. The denominator here has additional multiplication in it. So the way you want to think about this, you have to use parentheses, okay? So let me kind of set this up for you. You have log base 5 of 2 to the 4th power minus, I'm going to use parentheses here, you're going to have log base 5 of 3 to the 4th power plus, because of that multiplication there, log base 5 of 7 to the 24th power. Now, why am I using parentheses, or in this case, they're actually brackets, just I'm referring to any grouping symbols that you're going to use. But Why am I using brackets here? Well, I'm using that because I want to subtract away this whole thing, right? This is from my denominator, so I want to subtract away the whole thing. So I've got to use brackets or parentheses or any grouping symbols that you can kind of think of. All right, so the next step here, you just put equals. We have log base 5 of 2 to the 4th power. Then minus, you'll have log base 5 of 3 to the 4th power. Then this minus would be distributed to this. So you say minus log base 5 of 7 to the 24th power. All right, so now let's kind of scroll down and get a little bit more room going. We're going to bring our exponents down in front of each one of these. So we'll have 4 times log base 5 of 2 minus 4 times log base 5 of 3 minus 24 times log base 5 of 7. All right, let's take a look at a note. So we have log base 8 of 99 times the cube root of 7. So again, I'll say this is log base 8 of 99 plus, right, I have multiplication there, log base 8 of, this guy right here I would write with a fractional exponent. So I would say this is 7 raised to the 1/3 power. Now I want to bring this guy out in front. So let's say this is log base 8 of 99 plus 1/3 times log base 8 of 7. All right, let's take a look at a note. So we have log base 10 of the 4th root of 5 over x squared y cubed z. So again, I think about log base 10 of the 4th root of 5, I could write as 5 raised to the 1/4 power. Then minus. I'm subtracting away all this. So I've got to use, again, some grouping symbols. Parentheses, brackets, whatever you want to use. So let's just do brackets. You will have log base 10 of x squared. And then you'll have plus, let me kind of scooch this down so I'm not going to have enough room. So plus log base 10 of y cubed. And then plus log base 10 of z. And the grouping symbols are just reminding you to distribute that negative to each term. So if I keep simplifying here, I'll have log base 10 of 5 to the 1/4 power minus, right, this will go over here, log base 10 of x squared minus log base 10 of y cubed minus log base 10 of z. Okay, let's scroll down a little bit, get a little room going. So let me make that 3 a little bit better. And I'm going to bring all these out in front. So that, and that. So we'll say this is 1/4 times log base 10 of 5 minus 2 times log base 10 of x minus 3 times log base 10 of y, and then minus log base 10 of z. All right, so now we want to condense each to a single logarithm. So we have 2 times log base 2 of 6 plus 4 times log base 2 of 11 plus 4 times log base 2 of 5. So we're kind of undoing these properties we just used to expand things. So the first thing is I know that if I have 2 times log base 2 of 6, I could write this as log base 2 of 6 squared, right? This would just go back up here. Then plus, if I have the 4 out in front, I know I could write it as up here. So log base 2 of 11 to the 4th power. And then plus, this guy could go up here. So log base 2 of 5 to the 4th power. Now I have addition. So addition, you go back to multiplication. So everything is log base 2 here, right? So in other words, it's going to be log base 2 of this guy times this guy times this guy. So 6 squared times 11 to the 4th power times 5 to the 4th power. So in most cases on a test or your homework, this answer is good enough. I realize that we could multiply all this stuff together. It'd be a really big number. We're just proving that we can kind of move back and forth. If you wanted to do it, your answer would be 329,422,500. So log base 2 of, again, 329,422,500. But again, this answer right here is perfectly acceptable. What about 5 times log base 9 of x plus 5 times log base 9 of z minus 15 times log base 9 of y? So again, these are all going to go back up here. So we'll do that first. So we'll say this is log base 9 of x to the 5th power, and then plus log base 9 of z to the 5th power, then minus log base 9 of y to the 15th power. All right, now the next thing we want to think about is we have log base 9, log base 9, log base 9. So log base 9 of what? We know these two, because there's addition here, this is multiplied by this. So it would be x to the 5th power times z to the 5th power. Then I have subtraction here. So these two are going to be in the numerator. This guy right here that's after the subtraction sign, it's going to be in the denominator. So this is over y to the 15th power. So that's going to be your simplified answer. So log base 9 of x to the 5th power times z to the 5th power over y to the 15th power. All right, let's take a look at one more problem. So we have 1/3 log base 4 of x plus 2/7 log base 4 of y minus 3 log base 4 of z. So again, I'm just going to take all these back up real quick, and we'll start out with that. So we'd have log base 4 of x to the 1/3 power plus log base 4 of y to the 2/7 power minus log base 4 of z to the 3rd power. So this equals what? Well, we'll have log base 4 of, I have my addition here, so this one times this one. So x to the 1/3 power times y to the 2/7 power. So we have this subtraction involved here. And so we know this is going to be over this z cubed here. That's what comes after the subtraction. So that's going to come right here. So you end up with log base 4 of x to the 1/3 power times y to the 2/7 power. This is over z cubed.